Alright guys, for this week's lecture I'm going to go through and go over some of the extra add-ons SOLIDWORKS has available. Most of it obviously revolves around creating just parts and assemblies, but some of these other things can be really useful in certain situations. So first off, to get to this stuff, go up to, once you've opened SOLIDWORKS, go to Tools, and scroll all the way down and go to Add-ins right here. And it'll give you this little menu that allows you to either activate stuff at one time or just activate it every time you start up SOLIDWORKS. So the three I'm going to go over today are PhotoView 360, which is the ray tracing based renderer that comes in SOLIDWORKS, SOLIDWORKS Motion, which allows you to do kinematics with various assemblies, and then SOLIDWORKS Simulation, which is basically finite element analysis, which allows you to put loads on a part and see how it deforms and see how the stresses just transmit through that part. So first off, I've got open here a case I used on an aircraft not too long ago that I wanted to do finite element analysis on. What I'm trying to find out is, this is actually the tail boom structure from that aircraft, and what I wanted to know was, in our worst case tail loading, is this thing going to break? How strong actually is it? So to start figuring that out, I put together this assembly, and now notice all I really care about is this middle tube here. This is actually made out of carbon fiber, even though it doesn't show it in the assembly, but I've gone through and set material properties to make it act like that. I've also have these two kind of collets on the end of it, and that's just to give me a much easier surface to apply my fixtures and loadings to, which I'll talk about in a minute. So once you have the simulation package enabled, and you've got the simulation tab up here, down at the bottom of the screen, kind of like where we found the motion study stuff, you should have a simulation analysis tab open. So to get to that, you'll open that, and you'll notice that I've already got this case set up. So I'm not going to redo everything in front of you, but I'll just go over kind of what everything does individually. First off, for a case like this, all you really need is a material property that works for the whole assembly, a fixed point, and a load. In this case, I did a pressure distributed over that collet. So let's start off with the material. To do that, you can do this at the individual part or assembly level, but I like to just do it in the FEA case, and just go up to Apply Material here, and you'll see that I've created a custom one under this Custom Materials folder actually, and I just looked up bulk properties of carbon fiber online. Obviously this isn't great. If you can get a FEA package that can do different layers of carbon fiber and actually simulate how those layers interact, that's much better. And I think SOLIDWORKS can do that, but I don't have it installed on this machine. So for this case, I just did bulk properties, which are, elastic modulus, Poisson ratio, shear modulus, everything that describes how that material reacts to forces. So I just set this custom material to all three parts, even though I really only care about the middle one. These two are thick enough that they really don't deform much. So once you have the material set, just go through and decide where you want the part to be fixed. In this case, I have the tube mated to the collet here, and I just said that this top surface of the collet has to be fixed in all three directions. And you can see on there those little green arrows go through and say that it's fixed in all orthogonal directions. So to do that, just go to this Fixtures Advisor, and they have a little wizard that walks you through everything. For this, I'm just going to go through the one I already created, say edit definition on that, and you can see that I just said fixed geometry on this whole face. Now next you just need the load on the end of it, which I decided to model as a pressure. You can do point loads in SOLIDWORKS, but you're generally better off avoiding them, because a point load is something that doesn't really exist in nature. It's always going to be a pressure distributed over some face. And in this case, we actually have this tube being held in by a section of cardboard that then goes onto the rest of our structure. So something like this better approximates the actual loading case anyway. So the idea is just to get as close to how you're actually going to install this as possible. So to do that, I did an external loads advisor up here, and that's the same thing. It goes through a little wizard to just kind of walk you through that. And for this one, I'll go through and show you which settings I have. All I did was say it was a pressure force on this top face, and that it was 9 1/4 psi, which is really close to what our it represents our load case, basically. So once you've got that set up, that's basically all you have to do before you run this. A little bit about how these work. What SOLIDWORKS is doing is it's going through this 3D geometry and making a grid system throughout that it's then going to solve the differential equations that define how it reacts to those forces. And that grid system is usually called a mesh. So before you actually run it, it's a good idea to go to this Create Mesh option, and it says it's got to throw away all my stuff, but that's okay. And it asks you how fine you want that mesh. That means basically how many times do I want to solve this equation throughout the part. So I usually pick something relatively fine. That's okay. And once you click OK, it automatically goes through and creates that grid throughout your part. And you see it just finished, and that's actually how I'm solving the equation of this beam now. Each node is a location where that differential equation is being solved. And then it interpolates between the rest of that to get the plots I'll show in a little bit. But once you've done that, I'm just going to right click and say Mesh and Run on that, and this is where it's actually solving for all those forces. Now it should go through, and it shouldn't take too long. I think this case only takes a few seconds, but if you have a huge assembly with 20-30 parts, that could take hours easily. And if you did a really fine mesh as well. So these things tend to scale exponentially on computational time, so just be careful with that. You'll see I pulled up my results automatically, and this is showing the stress in the beam, which it shows a stress concentration right at the end of my fixture here, which is kind of what you'd expect in this case. I could probably modify that fixture to be a little bit more accurate, but in this case it's not too bad. If you want to see how much it displaces, there you go. Obviously, the end of it is displaced more than the stuff that's fixed. The strain, high strain, same place as the high stress. And then factor of safety. That means, can this withstand the load case? My minimum factor of safety is 5.5, so yeah, it probably can. Also, something you'll note, this displacement looks huge for not that much pressure, especially for a relatively sturdy carbon fiber beam. But look at the actual scale here. This is only 19.6 millimeters at its worst spot. So it's a centimeter, almost 2 centimeters. That's really not that bad. This is exaggerated heavily from what it actually looks like. So just be aware, don't just take the picture at face value. Actually go through and look at the numbers on the graph and see what's actually going on. Alright, so that's all I'm going to do on finite element analysis. Next I'm going to go over a little bit on the motion study and analysis features. Now, to get to this, again, make sure you go to Tools, Add-ins, and turn on SOLIDWORKS Motion. And just like we did this in a couple lectures ago, go to the Motion Study tab, and it should load for a second. And once that's done loading, you can pull up a timeline that kind of represents a video of how your part is changing over time. It's similar to, say, Blender or Cinema 4D or something like that, but it's actually solving kinematics in this case. Now, this case is kind of interesting. It's a little assembly of an egg that we've added a suspension system to that just follows these paths as it falls due to gravity, which is also calculated by SOLIDWORKS, and then it hits this landing pad and bounces. So, to modify something like this, I'm going to assume you have this assembly already created. But to add the motion properties to it, just make sure you have this tab on motion analysis, and then you just go through and add springs on your suspension bits. So a spring on this beam basically, and then do one on this beam as well. And then add a contact mate, which basically says that you have to check for collision between two objects, and then add gravity to the thing and just say calculate. It's actually really simple. So in this case, I'm going to go through and show you the settings we used. This linear spring, edit feature on that. You can see it is actually between this edge right here and that edge. And that's all the information it needs. Beyond that, you can specify a spring constant, which is how stiff the spring is. You can specify a free length, and if you want it to be a damper as well, you can specify that. So that'll help get rid of some excess motion after it actually hits. So we just did that on all 3 legs, and then this gravity feature is really easy. All you do is click on the apple there. And in this case, we set it to moon gravity, but you could set that to 9.81 easily if you wanted something on Earth. And then all it wants is a direction. In this case, Y does work for straight down, so that's what we want. And then the last thing is this contact mate, which basically we just told it, I want all the parts on the egg, so everything in blue there, we just clicked on in this first box, and then everything in pink, which is the surface, we clicked on in this box. And now every time step, every time it calculates this solution, it's going to check and see if those things are in collision. If they're not, it doesn't do anything. If it does, it responds appropriately with a normal force. So as far as setting up this problem, that's basically it. It's really easy. I just suggest you guys kind of play around with it. Now, before you actually get a video on it, the first time you do this, you have to click this calculate button instead of just the play button. So for this case, I'll just click calculate, and it's going to go through and it's solving as fast as it can what the motion of that egg lander actually is. And you see it hits and kind of bounces a little bit, and then eventually it will damp out. Let's say I only want to calculate up to this point. I can go back and play this, but for this 1.8 second to 3 second mark, I don't have any data, so it just freezes. If I had let that go throughout the whole thing, you would actually have video up to that point. So let's go back to 0 time here, and then I'm just going to edit one of these springs to be much, much stiffer. So this is the one kind of facing us here. Instead of 2, I'm going to make it 20 pounds per inch. So now that that's saved, I'm going to recalculate one more time. And it's already kind of freaking out, but that's okay. And you see it absorbed much more energy, and the other ones didn't have enough force to be able to keep the whole thing from rotating. So instead of landing and just bouncing a little bit like we wanted to, that really high spring constant now has caused the lander to tumble over and fall on the surface of the moon. So other than that, that's basically all you need to know to use these motion analysis tools. As with all this stuff, I just suggest if you're interested in it, just play with it for a little while. There are usually some pretty good tutorials online as well. Alright guys, last I'm going to go over the rendering tools built into SOLIDWORKS called PhotoView 360. And this doesn't really tell you anything you didn't already know about your part, but it can be good for producing marketing materials, report covers, that kind of thing. Plus it just looks pretty cool. So to show this off, I've gone on a site called grabcad.com and downloaded a light cycle model from Tron. That website's kind of cool. It's basically just a place where people upload open-sourced CAD files for just about anything you can think of. So if you're looking for something you don't really want to do it yourself, just check that out first. So in this case, to start a render, it's relatively simple. Just go through and to get to this tab first off, make sure you have it enabled in Tools Options. Then it's usually under Office Products. You need to enable it here, and then that'll get you this Render Tools tab. So once you have that open, you can go through and start clicking on Edit Appearance and do that on individual faces. Like say, if I want this face to be that color, you can do that. And see, it changed the whole model in that case, so I'd have to kind of play around with how I was doing it. But you can kind of see this guy's gone through and made this face turquoise as kind of an accent, and he's gone through and done rubber on the tires right here. Just kind of adds some detail to it and makes it look cool. So once you've done that, I like to go through and set up a camera next inside SolidWorks. So I've already done that. In this case, I've done a wide-angle lens, kind of doing a front quarter view, basically, of the car. To do that, just go into View, Lights and Cameras, and you can add a camera right there. In this case, I'm just going to go into the properties of my one I've already created. And you can see you get kind of a split view here where it shows you where your camera is in space and all of the properties of that camera on the left here. You can do depth of field properties if you know anything about photography, or you can just pick a lens and go with it. In this case, normally I think it defaults to a 50mm and 85mm. Just to show you the difference between that, I'll switch to an 85. You'll see my field of view has shrunk considerably, so I'd have to zoom out a little bit if I wanted to use this. But it's also much less distorted. So if you want kind of a true projection, you're probably better off using something on the telephoto side. In this case, I kind of like the distortion, so I'm going to leave it on 35mm. Now, also before you do the render, it's a good idea to go to this Edit Scene button and just pick a set of background and lights that you think fits with the part. This actually handles most of the details for you by setting up a 3-point light system, background color, and all the properties that you'd normally have to go through and tweak individually in most other software. So in this case, I kind of like the blue one. I'm going to keep it there. Also, just a good thing to have open when you're doing this, you can click this preview window button, and this will show you what the ray traced version is actually going to look like in real time. It doesn't have great settings, but it's fast enough in most cases that you can get a good idea of what you're actually changing when you mess with some of these options. So I'll go back to Edit Scene, and let's say I want the orange now. It updates in real time and shows you exactly what that's going to look like. And actually that looks pretty good too, so I'm going to leave it there. Now before you do the final render, just go to this options button, decide what size screen you want. I normally do this in at least 2x 1080p, but for this video I'm just going to do a really low res one. You can change the quality of both the preview render here and the final render, and also add some extra features on top of it. I usually like to use this best setting on the final render and then a really high resolution, and that tends to work out pretty well. You can always change the file format as well. PNG has worked out pretty well for me, but you can kind of experiment with everything else. So once you have that set up and it looks pretty good in your preview, just say final render, and it'll go through and do some pre-pass stuff relatively quickly. And then once it's done with that, you'll see it'll have 4 orange boxes right there that show what each core is working on at the time. So I have a 4-core computer. It's doing 4 of those at the same time. If you have 2, it'll do 2, 6, same kind of thing. So that's pretty quick. Once it's done with that, you can just click this Save Layered Image button. And I'll just put it on the desktop as a random file name. And click Save. And then we can go see what it looks like. And there you go. That's what it comes out with. So again, that's pretty simple to use. Just play with it. If it's something you're interested in and you'd like to have something for a report or a PowerPoint presentation that kind of goes over what you did building a say your 3033 robot or something, this can add a little bit to that. So otherwise, that's all I planned on covering this week. If you guys have any other questions about advanced features of these things, just come talk to us and we'll see if we can help out.